not at that. So if I'm writing somewhere on the paper and you can't see it, you gotta tell me. You gotta tell me like shift the paper around or whatever. Okay, what we're gonna start with is counting around the circle and putting our angles on it. Okay, so first of all, and that's what the blanks inside the circle are for. So we've got 0 or 2 pi, and I'm gonna go ahead and get my pi over 2, my pi, and my 3 pi over 2 on here. And then the ones that are smack in the middle of each quadrant, those are my pi over 4s. So I'll count up by my 4s, so this is 1 pi over 4. Then we've got 2 pi over 4. This one will be 3 pi over 4. 4 pi over 4. This one will be, the blank's in a weird spot, 5 pi over 4. Then we get 6 pi over 4, and then the middle one over here is 7 pi over 4. Okay, then we're going to go by our pi over 6s. All right, so we got 1 pi over 6. 2 pi over 6 gives me my pi over 3. 3 pi over 6. 4 pi over 6 gives me 2 pi over 3. 5 pi over 6. 6 pi over 6. 7 pi over 6. 8 pi over 6 is going to reduce to, what does it reduce to? 4 pi over 3. 9 pi over 6. 10 pi over 6 reduces to 5 pi over 3. And 11 pi over 6. All right, so we got our angles on there. Now, those parentheses outside the circle, that's where we're going to put x and y coordinates. This is called a unit circle because the radius has a length of 1 unit. So if I'm plotting xy points, so if I want to plot this point right here in the xy plane, I'm going to go over 1, because the length of the radius is 1, and then up and down 0. So that's 1, 0. Pi over 2, I go left and right 0, but up 1. So I get the coordinates 0, 1. For pi, I'm going to go -1, 0. And for 3 pi over 2, I go down -1, so I'm going to get 0, -1. Okay, the rest of the circle is going to get filled in with 3 different numbers. Okay, they're either going to be, and these numbers come from drawing a right triangle and using the Pythagorean theorem on it to get the hypotenuse would be of 1, and you're going to see one in a second here. And then we get the side lengths going in the x direction, y direction. Okay, and there's 3 numbers that are going to happen when you have a hypotenuse of 1 in a right triangle using these angles. Okay, those numbers are either going to be square root of 2 over 2, 1/2, or square root of 3 over 2. Square root of 3 over 2 is approximately 0.866. All right, we're going to start with the pi over 4s first, because the pi over 4s are the easiest. The pi over 4s get square root of 2 over 2, comma square root of 2 over 2. So if I were to draw a right triangle going to pi over 4, the distance of both sides of that triangle are square root of 2 over 2. will exist for all of the over fours. All the angles where I cut my circle in the fourths. I can draw, it's a square in this case, it'll be rectangles for the other angles, a square connecting those angles, and I know that's where all the root 2/2's go. Okay, now the answer is not root 2/2 for every single one of these, but I'm going to start with that. Now, the signs are going to be different depending on what quadrant I'm in, right? When I went over to the right and then up, I get positive x direction, positive y direction, so I got positive root 2/2, positive root 2/2. If I go to 3π/4, I'm going in the negative x direction, positive y direction. So I put a negative in front of root 2/2 for the first part of the coordinate. If we go to 5π/4, we are going negative x direction, negative y direction. Both of them are negative. And if we go to 7π/4, I'm going in the positive x direction, negative y direction. I put a negative for the y component. Okay, that leaves 1/2 and square root of 3/2 for all my other angles. And for all the other angles, all the over 6s and over 3s, it's a combination of both of them. So you're not going to get root 3/2, comma root 3/2. You're going to get 1/2, comma root 3/2, or root 3/2, comma 1/2. So how do we decide that? Let me draw a triangle going to π/6. Okay, we know that this whole length is 1. And if I extend that, this whole length is 1. And I told you square root of 3/2 is approximately 0.866. So almost 0.9, right? So 0.9, really close to 1. And 1/2 is the other one. So for this triangle, I drew an orange. Which part of it, the x or the y-axis, looks like it's really close to 1? That would be this one, this side, right? It went almost all the way over to 1. And when I look at this total length, that's halfway, right? So in the y direction, I got the 1/2. So my coordinates for π/6 are going to be square root of 3/2, comma 1/2. That's going to be true for all the over 6s. So I'm going to draw a rectangle connecting my over 6s. I'm going to fill every single one of those in with root 3/2, comma 1/2, and then we have to decide what signs they get. Okay, so this one is also root 3/2, 1/2. This one, root 3/2, 1/2. This one here, root 3/2, 1/2. Okay, now, we already figured out what the signs are supposed to be. In quadrant 2, we have negative x's, positive y's, so I put a negative on my root 3/2. Quadrant 3, they're both negative. Quadrant 4, I have positive x, negative y. Now, for pi over 3, I get really the same triangle if I wanted to draw it this way. It's really the same size triangle as my pi over 6, right? But my x direction and y direction lengths are flipped. So if you can draw the triangle for pi over 6 and decide which one gets root 3 over 2 and which one gets 1/2, then you can fill in the pi over 3's by switching them. So this one's going to be 1/2, this one's going to be root 3 over 2. I'm going to draw another rectangle, connect all my over 3's. And fill them in, all of them with 1/2, comma, root 3 over 2, and then we put the signs in. Okay, quadrant 1, x is negative, quadrant 2, both of them are negative, quadrant, I'm not saying the right quadrant numbers. Quadrant 2, the x is negative, quadrant 3, they're both negative, quadrant 4, the y is negative. Okay, so that is our unit circle completely filled in. You see why I told you to bring highlighters? It's to draw the rectangles. Okay, will you pause that video for a minute?